In our last video, guys and gals, we dealt with Pythagorean theorem and we were solving for the hypotenuse. And in our final problem, we recognized that that problem asked for something different. In that case, it asked that we find a leg measurement. So that's what we're going to do today. So before we get into the actual details of it, let's remind ourselves the Pythagorean theorem looks like this. We've got a squared added to b squared equals c squared, where a and b are the legs, and c is the hypotenuse. Okay, and not only is a and b the legs and c the hypotenuse, but when we draw it out, again, we'll draw a nondescript right triangle here. A and B are here. Again, legs make up the right angle. And then C, of course, being the hypotenuse. And we found that using this was pretty easy. We found the leg measurements, just simply plug those values in, squared them, added together, took a square root, and we had the hypotenuse. Today, the problems are going to look different. For example, and by the way, a lot of people get hung up on the right triangle having to look like this. I'm going to draw the right triangle from a number of different perspectives, just to show you that it doesn't matter how the triangle is oriented, just so long as we know which side is which, we can do these problems. For example, let's draw this first right triangle. We're going to draw the hypotenuse down here. We'll draw the 90-degree angle over here. So again, it doesn't matter how the triangle is oriented, just so long as we know which is which. So in this case, we know the hypotenuse already as 12 units. And we know that one of the side lengths, the other legs there, is 10. Our question is, what is the other leg? So Pythagorean theorem hasn't changed. It's still a squared plus b squared equals c squared. So let's take what we know, we'll plug it in, and see what we don't know and work from there. So first thing I don't know, let's grab this side. I don't know what this first leg is, so I'm going to go ahead and call it A. Now, we could call it B as well. It's up to you, but I'm going to call it A in this case. So a squared, I'm not sure about. B squared is the other leg measurement. Well, in this case, I know the other leg. Remember, legs make up the right angle. So in this case, 10 squared. And then our last number here, this 12, is the hypotenuse. And I know it's the hypotenuse because it's opposite that right angle. So my 12 goes here. Well, now it's just a matter of working this out. So let's take 10 squared. So a squared doesn't change. 10 squared is 100. 12 squared is 144. Now, this is where things are different. Okay, if we look at another Pythagorean theorem problem, for example, let's look at our notes from when we did the word problems. After I take a and b and square it, I add them together and then move on with my work. With these, notice, now that I've squared our 10 and our 12, I've got to get a by itself. Well, notice a is here and the 100 is with it. That means I need to get rid of this constant. I've got to eliminate this 100. So instead of adding the 100 and the 144 together, I'm going to subtract the 100 from both sides. Notice that makes a squared on a side all by itself, no other number. And then on the other side here, 144 subtract 100 is just 44. We'll end the problem the same way we did before. Notice I've got a squared, but I don't really want a squared. I just want to know side a all on its own without the power of 2. So to undo powers of 2, we said the inverse is a square root. So let's do that real quick. Now, 44 is not a perfect square number, so we're going to have to round here. So a equals, and in this case, let's just round to the 10th position. That's a perfectly valid way to do it. So second, x squared, and then 44. So in this case, we get 6.63. Who cares? We're going to round to the 10th position. So that's a 6. We look over, it's a 3. So it means we round down. So all of this goes away. And we're left with roughly 6 and 6/10. And we'll say units since we don't know what we're measuring in. So that's the major difference. When we're solving for a leg, instead of adding our two squared numbers, we end up subtracting them from each other. And notice, this number, 6 and 6, had better be shorter than this hypotenuse measurement. If you come up with something longer, then you have done something wrong. Okay? Don't, I repeat, don't get a number that's too big. In this case, you should have some idea whatever we have here had better be smaller than 12. Let's try another one. How about something, I don't know, Let's do a problem like this. Kind of a long and narrow right triangle here. So in this case, our one leg length that we know is 4. The other one will be 9. And in this case, not leg, but hypotenuse. And again, I know this is a leg because it makes up the right angle. And I know this is a leg, it makes up the right angle. And then, of course, this final side length is the hypotenuse. It's opposite the right angle. So we need to figure out this leg measurement here. And again, that leg makes up the other portion of the 90-degree angle. So last time we let A represent our missing side. This time I'm going to let B represent our missing side. And notice it doesn't matter in the slightest so long as it's a leg measurement. So here we go. We're going to take 4 squared, because that's the A in this case, add it on to B squared, and then that's going to give us C squared, or in this case, 9 squared. So first thing we need to do is square everything. So we'll take 16 added to B squared, and then that's going to equal 81. Now remember, this is where things get different. Typically we would add the A and B squared, but we don't know B squared at this point. So we need to get it on a side by itself. So the thing I'm going to do is subtract, in this case, 16 from both sides, and that will get B squared on a side by itself. And again, if you need help with the calculator, don't fear, grab a hold of it. So we'll take 81, subtract 16. In this case, we get 65, if I can write. Now notice 65 is very, very close to a perfect square number. In this case, the perfect square being 64, which is 8. So we should get a number that's very, very, very close to 8. So if we take the square root of our answer, so second answer, and then that gives us, let's see, 8.06. And if we round to the tens position, that's roughly 8.1. So again, we took the square root there, getting ahead of myself, and that is 8.1 units. In this case, we don't know how long we're measuring. We're talking about inches, yards, who cares? So again, that's the major difference. We're going to have to figure out that leg measurement, and we do so by subtraction, and then in the end, we take that square root same way we've done before. Let's try one more. Oh, let's see. Let's think of a good one. How about this? How about something that's kind of close? So this one's almost isosceles, so we'll draw it this way. Almost an isosceles right triangle. Very, very close. I'll get that right angle drawn in a little bit better. There we go. So we've got 14 for one side. We've got 10 for another. And then, of course, one side we're still missing. Now let's talk about what are these sides. Well, notice here's the right angle. So that makes 10 one of the legs. Notice this side length of 10 helps make the right angle. So this could be either A or B. Our unknown here is the other side making up the right angle. So that could be either, again, A or B. This 14, however, has to be side C. It's the hypotenuse. It's opposite that right angle. So let's get started. So I'm going to let 10 in this case be A. So 10 squared added to what we don't know yet, so we'll call it B squared, is equal to C squared. In this case, that's 14 squared. Well, I know 10 times 10, that's 100. Still working on B squared, so we'll get that in a minute. And then 14 by 14 is 196. Again, we want B squared all on its own, so we got to make that 100 go away. So let's subtract 100 on both sides. So again, instead of adding, if we had both A and B, we would add them together. Since we're looking for B in this case, we'll subtract our A squared from our C squared. And that's going to give us B squared is equal to 96. Now remember, 96 is a number really, really close to a perfect square. In this case, 100. Its square root is 10. So we're going to be just shy of 10. So it's going to be 9 and change. So this triangle would actually be very, very close to isosceles. So we'll take the square root to undo that power of 2. Remember, we just want what B is. We don't care about B squared. We care about B. So again, we'll take the square root of 96. And in this case, 9.79. And if we're rounding to the tenths position, well, that's 7 and then a 9. So we need to round up. So 9.8, and we'll say units. We're not sure what we're measuring in. So notice this 9.8 that we just arrived at, these two sides are almost identical in length. But again, notice the 9.8 is still less than the 14, still smaller than that hypotenuse. So today, this is what we'll be working on. Still Pythagorean theorem, still A squared added to B squared equaling c squared. That hasn't changed. The difference, though, is that instead of trying to find c, instead of trying to find this hypotenuse, we'll be looking for either a or b. All right, I'll see you in class. Make sure you've taken good notes. We'll see you then.